Welcome everybody back to Young Engineers of Today. Like I said, we're going to be continuing with 3D modeling. Today we're going to take a look at MeshMixer. And I'm going to go ahead and put this into the chat box so you guys can follow the link and download it. It's about 60 megs, so it should take a few minutes. But go ahead and download that now and install it. And in the meantime, I will... Oh, I see we got one more person who joined. Let me go ahead and throw that link back into the chat box again. At least I think so, unless my mind is playing tricks on me. Yeah, go ahead and download it, install it. In the meantime, I'm going to tell you what exactly MeshMixer is, or at least an overview. MeshMixer is another Autodesk product. I swear we're not advertising Autodesk. This is just because a lot of their products are free. They're, easily accessible to download. They're available for the computer, and they have a decent amount of documentation available that you guys can refer to. MeshMixer is kind of the exception to that rule. There aren't a whole lot of tutorials on MeshMixer, but that's okay. That's why I'm here today, is to take you through a very basic walkthrough of how MeshMixer works and what you do with it. But in essence, what it does is you can take 3D models and you can just combine them. Literally attach other 3D models to 3D models and create new 3D models from it. I wonder how many more times I can say 3D models. At any rate, it's an interesting little program. It's you have to work with 3D models. You can't start with something empty, so that is to say, it's not like Fusion 360 in that sense. Fusion 360, you can start drawing something in 2 dimensions, and turn it eventually into a 3-dimensional drawing. With MeshMixer, there aren't any tools really to draw. You can import 3D models and then work with them, but that's really it. You can't create something from nothing in MeshMixer. One of the handy things about MeshMixer is it's great for setting up for 3D printers. It has a number of 3D printers in its database, including their dimensions and things like that, so you can sort of get a preview of how your new model will sit on the 3D printer print bed. In addition to that, you can also send it off to get printed by various services on the internet who will print it out for you and then send it to you. We'll get into more detail on those services and stuff like that later, or just rather how that works. Keep in mind, though, that that's a fairly expensive thing, and I'll explain more about that later. Anyway, let's see here. Trying to think of anything else I can talk about before I dive right into it. I will say in the ensuing weeks we are going to, like I said, start with Python. We're going to work with Raspberry Pi, start doing some neato stuff with that. Hopefully the Raspberry Pis will come by in time, but I believe we'll be starting with Python on its own, just so you guys have like another week to get your Raspberry Pis. So we'll figure that out as we go. I also wanted to apologize for today's session because I don't really have a lesson made up, presentation. So I am going to be going off of basically just winging it. So it might be a little bit here, might be a little bit there, might be a little bit rambly at points, but I'm going to get everything out that you guys need to know. Anyway, hopefully you guys have finished downloading MeshMixer at this point. If not, that's okay. I'm going to go through this stuff pretty slowly, so you should be able to catch up reasonably quickly. So once you have it downloaded and installed, go ahead and open it. You will get a license agreement. I'm sure you guys are pretty familiar with license agreements at this point, and already before I started, telling you to agree to the license agreements. So, you don't really need me to explain what to do in that situation. again. Anyway, once that's done, you'll get this little panel of like 7 buttons here, right? You've got import, you've got open, you've got 1, 2, 3D, and then you've got a little picture of a rabbit, and a little picture of a sphere, a little picture of a plane, and a little picture of a keyboard. You'll notice that there's something missing. There's no new button. Like, you know, when you first open up Word or something like that, and you get like the, oh, I can open up a new, or create a new document, or open an existing document, that kind of a thing. Usually new is an option that you see in a lot of things, like when you're first starting up Fusion 360, it asks if you want to create a new project. When you're starting up some of the other stuff we've been, oh yeah, Bridge Builder, Bridge Designer. It'll ask you if you want to start up a new project. You know, you've seen it a million times before. That's not here. Like I said, that's because you cannot work from nothing with MeshMixer. You have to start with a model. So import, in this sense, is your new button. And then you've got open, which is of course open up a project you've been working on. 1, 2, 3D, because it's an Autodesk product, you can download 3D models that you've worked on from the Autodesk cloud and put it into here. Then these first 3 down here are just quick imports. So you can import, you know, the bunny, you can import the sphere, and you can import the plane. It's the same thing as the import here, it's just one of those 3. Now there are more options than the bunny, the sphere, the plane. There's also like a goblin and an elephant, and I want to say like a shark too, and a couple of other things. But anyway, those are quick imports. For some reason, bunny is the first one. For some reason, bunny's used a lot. No idea why. Hey, whatever. Last one is keyboard shortcuts. Keyboard shortcuts is one of those things, you know, you can click on it, you can check it out. It's probably one of those things that's better to use once you get more accustomed to the program. And, you know, assuming that you're interested and you want to continue trying it out and using it. One thing to note, though, which is why I'm bringing it up, is that the navigation mode listed in the keyboard shortcuts no longer valid. These don't exist in MeshMixer. You can't switch to these. So you always use the navigation mode in the 1, 2, 3D apps. And then it's got like undo and stuff like that, which is stuff that's always existed. So we'll go ahead and close that out. And we're going to start out by importing the bunny. So here we go. This is the 3D model of the rabbit. And as you can see, it's made up of tons of little triangles, which, you know, links back to the point I was making last week about how 3D models are made up of like hundreds, or in this case, thousands of flat triangles. As you can see here, the number of triangles in this model alone is 10,996, which is a lot. It's, you know, nothing to sneeze at. And I've never really understood that phrase either. I guess you sneeze at small things because they get stuck in your nose, or you sneeze at things because you don't take them seriously. Whatever. Anyway, 10,996 triangles to make up this design. And you can see, if you zoom in on each one of these, that they're all actually flat triangles. True to my word, I'm not a liar. They're all flat triangles. It's just the sheer number of them means that a curved shape can be simulated. If we were to increase the number of triangles on this model, which we can do if we were so inclined, you would notice that the rabbit looks smoother. If we were to decrease the number of triangles, which is also possible, you would notice that he looks more polygonal. Blocky isn't really the right word for it, because he doesn't really turn blockier. He turns more like, if you've ever seen like Tron, the old Tron, or if you've ever seen like Reboot, that TV show from Canada, you'd maybe have a better idea of what I meant by that. Or really just any like cartoon or anything like that where they go into cyberspace and they run into like cyber things. They're either glowing or they're very polygonal. Anyway, the controls to navigate around should already be very familiar to you. Click and hold right mouse button and drag to rotate. Click and hold the middle mouse button and drag to pan. And then you can use the mouse wheel to zoom in or out. And it, yeah, that should already be old news. So with that in mind, let's go ahead and go over here to your toolbar on the left and to see what we've got here. So the first thing is the import button, and the import button is the exact same import button that you see in the beginning when you first open it up. It does the exact same thing. However, because you already have a model here, it'll ask you if you want to import a model to add to this design, so if you wanted to import a second model to attach to this one, or if you just wanted to import a new model and replace the rabbit entirely. So basically, if you want to import a model and attach it, or if you just want to start a new file. This little checkbox here, in case like everything's rotated 90 degrees on the x-axis, you can click this, and it'll bring it in so it's sitting against the ground. Like if the rabbit was laying on its side, you could click this, and it should automatically rectify that. The reason for that is because as computer scientists go, they can't really agree on what Z and Y are going to be. They can for the most part, but there are still those rebels out there who switch the Z and the Y axes. So because of that, you might get models that they're sitting on their side because the Z and the Y are flipped. If you'll remember back to the STL file that we looked at, how it's all just a list of coordinates, well, those are all X, Y, and Z coordinates. And if one program prints them out X, Z, and Y, and another program reads them X, Y, and Z, the entire model will come out and it'll more or less make sense. It'll just be flipped on its side. So if you click this, it'll come out and it'll be standing upright. But anyway, we're going to click cancel now because we're not really going to import anything. MeshMix is kind of like the meat and potatoes of the program. Well, at least for like the bigger, broader strokes. We'll get into that in a minute. It's the sphere with it's the creepy sphere with the face on it. And then select gives you the ability to select parts of the model or all of the model and modify it. Sculpt is a literal sculpting tool, which and we're going to get into all the more detail on most of these tools in a minute anyway. So don't worry if I'm like just kind of blowing through these right now. It's meant to just be an overview. Anyway, Sculpt is a literal sculpting tool. It allows you to modify the 3D on the 3D shape of the model. So like you might be able to see here, I am whittling down the ear on the bunny so that it is a different shape. And that's one of the things you can do with the sculpting tool, is you can remove superfluous pieces. You can make things smaller. You can mess with the size of your model at certain parts and everything like that. There's a lot you can do with it, so we'll check that out in a minute too. Then you got stamp. Stamp hasn't really worked for me, so I can't really tell you what stamp does, but I'm assuming it puts stamps on it. I don't know. Edit allows you to change various properties of your 3D model, including getting it ready for 3D printing, a process that many people in the industry call making it watertight. And I guess that just runs back to the point that the entire model is complete enclosed. There aren't any like floating, like the rabbit's head isn't like floating like a fraction of a millimeter off of the body, even though it looks like it's connected, that kind of a thing. But there's just sort of duplication, transform, align, various things where you can move it and change the size of things. Analysis allows you to check and make sure that everything's a-okay with your model. None of those aforementioned holes I was talking about, or gaps. It allows you to change some of the things related to the actual printing of the model and making sure it's ready for printing. Shaders is pretty cool. It's pretty straightforward, so I'm just going to show it to you right now. It's just, you pick a thing, you drag it on there, and it changes the appearance. It's not really necessary, but it's kind of neato. So like we can, give them this weird like beige pink pattern. Or we can make them golden and shiny. For now, I'm just going to keep them on the default matte. Although I want to see that one. That one looks nice. Anyway, default matte, I'm getting distracted. Export and print, we'll go into greater detail at the end, but those are print is the aforementioned printing feature I was talking about. Export allows you to save it to your computer, basically. Anyway, so let's go ahead and just dive right in, and we'll start out with MeshMix. So if you click on the creepy sphere, you'll get this thing over here, this list of items. Yours is probably going to look different from mine. Mine is on primitives. If you wanted to change that, you could just mouse over. Yours is probably going to be arms. You can mouse over that, and you should get a menu that appears off to the right. So you've got arms, ears, heads, legs, letters, miscellaneous, numbers, primitives, symbols, Tinkerplay connectors, Tinkerplay parts, and my parts. Now, these are all mostly self-explanatory. I'm sure you guys know what arms and ears and heads and legs are, and so same with letters and numbers. Miscellaneous, you can check it out just to see. Primitives are simple shapes. A lot of times those are used in something called CSG, or Constructive Solid Geometry, which I will explain later. Symbols, pretty self-explanatory, things like ampersands and question marks and stuff. Tinkerplay connectors and Tinkerplay parts, they seem like a proprietary kind of a thing that allow you to build just models from it. And then my parts is literally your library of parts. You can import parts into MeshMixer. The example I used at the time was, let's say you opened up a business where you built custom, like, little 3D printed robots for people, and they picked their robot based on like 10 different heads and 10 different torsos and 10 different sets of arms and 10 different sets of legs. So that's a lot of different permutations. You can either create all the different permutations and get them ready for 3D printing, or you can just put all of the parts into my parts, and you can use MeshMixer to slap together the robot based on an order each time somebody orders one. So that's a potential situation, an extremely hypothetical situation, but a potential situation in which you might use something like the My Parts category. So, I'm going to go ahead and I'm going to select arms, because like I was saying at 5, this rabbit needs something to defend itself against predators. Namely, it needs some big burly arms, an extra set of arms, so that it can fight people off and punch them in the face. Whoops. So if you just click and drag it, you can bring it over to the rabbit, and other than the big arm floating over here, discard. Okay. Alright, I'm going to have to undo a few things here. By the way, Control-Z is alive and well in MeshMixer. I haven't tested how far the Control-Z can go, but it seems like a fair amount. You might even be able to go all the way back to the beginning of the project, which is pretty cool if that's possible. So anyway, we got this human arm here, and you'll notice that if I click and drag the globe, it actually moves it around the rabbit. There are a few other things over here, but let's look at this left-hand menu first. So we've got size. This is literally the size of the arm. We can make the arm larger or smaller if we wanted to. We've got bend. Bend is a little strange. Bend just takes some of the walls of the mesh, because all of these are hollow. Like if I were to zoom way in and look inside this rabbit is hollow on the inside. And it's kind of unfortunate that they chose pink for the inside color, but yeah, the rabbit is hollow on the inside. Same with this arm. If we were to look in the direction of the arm, if we could, yep, there's the hole for the arm right there. So as you can see, the arm has already been attached to the rabbit. We can still move it around. Let's just undo that. I really shouldn't have zoomed in that far from that angle and tried to move it around. Bring the arm back. So anyway, the arm is also hollow. So what the bend does is it bends the walls of the mesh, which if you set it to a really high value can do really weird and kind of disturbing things like that. It rotated everything way too far, so we're going to set it back to 1. We'll just have it at 1. 1 is good enough value. Offset is how far away from the rabbit it is. You'll notice, though, that because it's attached to the rabbit, and it has to be attached to the rabbit in order to be a valid print, that it creates this sort of pillar off of the rabbit in order to compensate. which, you know, doesn't really look natural. We're not going to keep that, so I'm going to go ahead and undo that. Actually, first I'll bring it back. So we'll set the offset to 0, or we'll set the offset to -1. That's ridiculously far in the other direction. And then 1, and I can't move. Oh, there we go. You'll notice though that there's this crater kind of a thing here. It looks like actually from certain angles that the arm is punching its way out of the rabbit, which is kind of hilarious. But if we wanted to fix that, we could use this smoother here. Smoother. Really, I mean, if we wanted to be proper about it, I guess. And what the smoother does, as you can see, is it tries to reconcile the surrounding area and sort of give it a smoother curve as opposed to the kind of cratery thing that we had happening here. Now, keep in mind, you could go too far with your smooth, like if we set it to 10 here. That's actually working out better than it did the last time. Last time what happened was the... Oh, yep, you can see it a little bit here. You'll notice that the rest of the surrounding area is actually moved down in order to smooth it out so much that it's broken it further away. So we're just going to reset it to 0. And we're actually going to undo a few of these steps that we've done. So everything is back to normal. Descale is just change the scale of the further end of the arm. Fall off and tweaker. Don't really know because I can't really see an effect on them. We also notice though that there is a little thing around here. We've already noticed, or we've already seen that you can move around the arm with the little globe, but you can also rotate the arm with the circle around the globe by left-clicking and dragging, so we can make him look like he's winding up for like a super big punch. And then we can make the arm larger or smaller with the arrow next to the circle. So he's looking all kinds of like ready for fighting off predators. Now it should be said, once we get this in the proper position, that looks good. It should be said that we can click on this little white circle right here and we'll get a whole different set of options. So this first one, this flag looking thing, this one rotates the arm. Now this is different from the last rotate in that the base itself stays in the same position. As you can see, the arm just kind of twists itself up, and if we go all the way around to 180 degrees again, it rectifies itself, or 360, excuse me. And then this little triangle here, we can move that around and it changes the direction that the arm is facing in. So we can do, you know, make that look all kinds of strange. So there we go. We'll go ahead and bring that back to the way it was. And we'll hit accept. So he's got one arm, which is good for now, but he's gonna need a second one. So let's go ahead and add a second burly arm to the rabbit. Now if we just rotate this around, we'll notice that it's backwards. The thumb is on the bottom, and the human body doesn't really work that way. It works with the thumb on the top, like over here. So we can't really just rotate it. But what we can do is we can check the flip box over here. And what that does is it flips the arm around. So you'll notice when we rotate it back up, it's properly aligned. So this is handy to know in case, you know, you're working on a project that has like a left and a right kind of a thing, and you want to save yourself some effort because it means you only have to model like 1/2 of that arrangement. Like let's say you're making legs for those robots, again to bring back that that example. You'd only have to make like the left leg and then you could flip it and you'd have a right leg immediately. You wouldn't have to model a right leg in addition to that, therefore cutting down the amount of work you have to do. We'll hit accept. So there you go. We got two arms on the rabbit, and as you have already noticed, I'm sure, these arms are a different color from the rabbit. This introduces grouping. Now grouping is a pretty handy little thing, as we see when we go down into the select menu, because we're going to look at the select menu next. Grouping allows you, like normally when you double click on a thing, it selects that entire object. I should say it selects that entire group. Because these arms are a different color, which means that they're in a different group. And all group simply means is a collection of triangles. So this arm is a group because this is a collection of triangles that, collectively make up the arm. That's why this one's purple, that's why that one's flesh colored, and that's why the rabbit was white, because the rabbit is a different selection, or collection of triangles. A different grouping of triangles. But let's take a look at what select can do, because there's a few things you can do with select, including the ways that you can select different things. First things first, let me cough a lot and then drink some water. First things first, you can select by painting. It's really as simple as that. You can just paint, and you can change the size of your brush so you can select smaller amounts. And now notice what it's doing here is it's painting individual triangles. These triangles are going to be the boundary of your selection. You can never select a part of a triangle. That's just not possible. So your selection will end at the end of a triangle. So that's why it can be more useful to increase the number of triangles in your design. But keep in mind that increasing the number of triangles also increases the number of memory, or the amount of memory used, and it also can make it more tedious to select individual triangles if you're trying to get a precise enough cut. So you can paint on the model. We've already seen that you can double click the model in order to select an entire group of triangles. However, you can also, if you start clicking from off of the model, so somewhere where, like somewhere not on the model, you can start drawing a set of lines. Just clicking places a point, and then moving the cursor starts from that point. And if you close off that pen, it's kind of a box, but not really. Look at that. It selects everything within that box that is visible. Like, to the best of its ability, it selects everything within that box. You'll notice it selected the rabbit's head, the entire head, as well as all the way down his back, save for this one spot over here for some reason. But my OCPD can fill that in, and there we go. So what that does is that selects all of the model that's inside of the area that you drew, and it's perspective based. So if I were to, to do that same one over here, you'll notice we get a little bit of the arm, we get some of the ear gets cut off, some of the, no, it looked like it was at first, but like you don't get the entire arm, and his back remains untouched. So it's perspective based. Similarly to the box drawing, but also easier, we can just draw a line. Again, you have to start from off of the model. What good is this selection tool? What can we do with it? Well, let's see here. Let's say, Bunny's head is just not menacing enough. What if we were to use a bear head? I mean, I'm assuming that's a bear at least. What if we were to use a bear head? Well, if we were to drag this bear head onto the rabbit, that doesn't really work. Now he's just kind of got two heads. One of them's a bear head, and I guess this is pretty disturbing on its own. But, let's see if we can't change the rabbit's head. That might be good. So let's click cancel. By the way, keep in mind the way MeshMixer works is you'll pretty much always get like a window up here that changes the parameters of whatever you're trying to do. And you always get an accept and a cancel button to some degree or another. You might have other additional buttons, but there will almost without fail be those two buttons. If you do anything other than click accept, like if you click away from it, if you click cancel, if you hit escape, whatever, MeshMixer, it's still a bit of a tongue twister for me, I'm getting better at it, but MeshMixer will assume that you didn't want to do whatever it was you were just doing. The only time it keeps the settings that you've set, or keeps the changes that you've made, is if you click accept. And of course, you can still undo it after that point anyway. So nothing's really permanent in MeshMixer, but that's okay, because if you're like me, you make a lot of mistakes. So anyway, Let's go ahead and utilize what's called that little laser select method that I was just showing you guys. Let's go ahead and utilize that and select the, that's too much of the rabbit's upper head area, upper chest, whatever. There we go. Boom. Okay, so as you can see, we've just got like a little bit of ear up here that we can paint in, but we've got his entire head selected with more or less one stroke of, the mouse. So let's see what we can do. We've got edit, we've got convert to, we've got deform, and we've got modify. Modify allows you to modify the various aspects of the actual mesh. You can, this is more or less separate from, like, select all, we'll select the entire thing, select visible, we'll select everything that's facing towards the camera and is currently rendered right now. Invert selection, things like that. That more has to do with how you can select things. Deform allows you to change the shape of things, so you can smooth the head. You can transform it, and by that I mean change the size or move it around or rotate it or whatever. You can soft transform it, which is less, basically, less crazy transform, like it's within certain boundaries. You can warp it, which is a type of deform. You can convert it to an open part or a solid part. We'll get into open parts and solid parts later. Convert it to a stamp. We'll see that later. Well, we won't really look at stamps. But edit is the one that we're really interested in right now. We've got erase and fill, discard, reduce, remesh, extrude, extract, blah, blah, blah. So discard just straight up deletes it. Reduce reduces I think the amount of triangles used to build it. Remesh allows you to increase the amount of triangles used to build it, therefore making it smoother. Extrude allows you to, it's kind of like the press pull, so it's good for flat faces. Extract allows you to remove it entirely, separate it. Offset allows you to move it side to side or up and down, which is different from extrude because extrude is adding, material there, whereas offset, the triangles are just expanding in order to reconcile in order to reconcile the thing that's being moved. Join and weld boundaries are two different things. Weld boundaries is what we've been doing. It's for stuff like meshes, which are hollow on the inside. Join is for more solid objects that are not hollow on the inside. Like, for instance, if we were to just draw a couple of cubes here, I'm sure you can already imagine this in your head, but you might have one cube that is completely hollow on the inside, and you might have one cube, like it's like a cube of solid iron versus a glass cube or something like that with air on the inside. And so join is a different algorithm, and it has more to do with constructive solid geometry, which we haven't gotten into yet, but we will. So yeah, weld boundaries, separate, plane cut. Plane cut is just you can pick a plane, like a XYZ plane, and just make slices in the model and group things up by those slices. Flip normals is to mirror the object. Around specific axes and things like that. Fit primitive is if you attach a primitive to get it better to, fit. But what we're interested in doing is erase and fill. So erase and fill is going to get rid of this head, and it's going to try and close out the mesh with something that makes sense given its surroundings, which, it did a pretty okay job. If it didn't, though, we could always refine it with these we could always refine it with these sliders here, change the way it renders itself. Sorry, I was entranced by that. So we'll hit accept. So now we got a headless rabbit, which is unfortunate. Let's give him a bear head. Just go ahead and drag it on. So that looks derpy. Let's bring the bear head over here. We'll rotate it a little bit. Nope, too far. Rotate it a little bit this way. And we'll make it larger. Bring it up. And there you go. Hit accept, and you've attached a bear head to your rabbit. It's now a rabbit bear. A rabear, if you will. So what we've done is we've removed a part of the model, replaced it with some mesh, and then we attached a different model to it, and then merged those meshes. But that's all we've done so far, is we've done merging meshes. Let's see about some other stuff, like, for instance, primitives. Why do I bring up primitives, you ask? Well, that's because primitives are solid objects, unlike the meshes that we've been dealing with. And you can tell that because it's denoted with this little icon here. If we go to arms, you'll see that it's got like a circle thing, like a half moon, and primitives have a cube, blue cube in the corner, which means that they're solid objects. So I think in order to make our rabear look more menacing, we're going to have to add an earring to him. Because, I mean, that just only seems natural, right? Let's make it smaller. Not too small. We'll bring it down here. Actually, let's see if we can put it on the... No. We'll bring it... The other options... Still can't rotate it. Still is not amenable to being rotated. But that's okay. We'll use the offset here. And we'll see if we can't find a spot. Oh, I think I know. Maybe I don't. Apparently I'm the worst at adding bear earrings. There we go. That looks more like a hat for his ear. Anyway, you get the idea. I'm not going to sit here and fiddle around with this thing forever until I get an earring. Unless I make it larger and... Ah! That is one big earring. Okay, there we go. Let's say that. So anyway, like I said, this primitive is a solid object. Now enters constructive solid geometry. So constructive solid geometry is actually, I think it's pretty cool. I think it's a pretty interesting little concept. Basically, it's creating really, really complex looking solid shapes by taking really, really simple solid shapes, in this case primitives, and adding and subtracting them to one another. It's basically math on shapes, more or less. There are three operations you can do. You can do subtraction, you can do union, and you can do intersection. So in the example they have here, I'm just going to use Wikipedia right now because they draw it way better than I ever could. So let's say you have a sphere and a cube. And you slap the sphere, like you can imagine in your head, right on the corner of the cube, right there. Union in this case is like addition. So the final object is going to be the two of them smashed together like that. That is going to be the final shape that you have. is the sphere smashed into the side of the cube. Now on the opposite end you have subtraction, where you subtract one of the shapes from the other one, and basically take a bite out of it. So you imagine this is, I don't know, Pac-Man or something like that, going to town on a dot. Well, in that case, all the areas where the sphere was get removed from the cube. That's why there's this blue here. That's the very edge of the sphere on the blue cube, or sorry, the red cube. So yeah, now you got this huge chunk taken out of the cube. The third process is different from both addition and subtraction. It's called intersection. Now what intersection does is it takes the result of where both of those shapes are. So as you can see, whoops, we had to have a little bit of overlap in order for these two shapes to sort of merge with each other like this, right? In fact, if you wanted to be specific about it, there is an area that looks probably roughly something like this. And then it's got like a thing here. And it probably comes down from like the edge of the sphere like that. Oh, right, and it actually looks something like this. Hold on, let's clear the drawings and let's start over again. So this is why I had Wikipedia do it for me. So this is what the cube looks like inside, right? And we've got the edges of the sphere here. So those two areas overlap right now. Well, as one might imagine, intersection is where those two exist both at the same time. Portion common to both objects. There's another way to put it. So between those three operations, like this is how this shape is created by using a cube, a sphere, and a tube. You add two tubes together and you make a shape. You add a third tube to it, and you make another shape. These are all unions right here. And then you take the intersection of the cube and the sphere, and as you can see, it's sort of like a cut-off sphere, kind of, sort of. And then you subtract this weird tube shape from your cube-sphere intersection, and you get this final, pretty complex-looking shape. Like on the inside, it's got all these different like areas. Anyway, that is constructive solid geometry. It's where you take an object and you merge you merge them, a couple of primitives together in order to generate a new shape. So we're going to use Boolean union, which is, as you might imagine, this right here. Except. So now it is merged with the bear. So now he's looking pretty alright. Except let's mess around with some sculpting. So first of all, bear is going to look even, more serious if he has like a messed up ear, So we're going to reduce the size of our brush and increase the strength. And see, these are all the different types of brushes that you have. Drag pulls material out, like towards the camera. Draw, draw and draw two, same deal. Drag actually takes a triangle and sort of deforms it based on how you move your cursor. That's right. Flatten tries to make everything one flat shape, which is, not really what we're looking to do here. Inflate will, let's just go ahead and I can show you. So boom, see, it's adding like kind of like bumps to the model. Like if I were just to continue to use it, it's not really going to show for some reason. Maybe it'll show on his head here. Yeah, it's kind of showing there a little bit. Like there are a couple of bumps there. Let's undo those. We got pinch and we got move. These are all just, you can mess around with these. So we're going to use shrink smooth. And I'm just going to go ahead and go to town on his ear a little bit here. And if we rotate it around, as you can see, looks like he's got a chunk taken out of his ear. Like he got in like a fight or something like that. He totally wrecked somebody despite the fact that his ear got all messed up. So yeah, brush or sculpting allows you to change the actual model shape. Now there's this last one, paint vertex. So I'm going to hold down the space bar and it's going to bring up another menu. And this is just you know, you can set up some, like you can click on these tools in order to do the same thing that you can do if you have like a full mouse. So you've got rotate, you've got pan, you've got zoom. You can change the different ways the bear is rendered to smoothen it out and things like that. So we've also got color over here. So I'm going to click on this blue one for color, and this allows us to see the color of the actual object. So we're gonna put a little bit of blue on this bear, like right on his forehead right there. And he's going to have a little bit of blue right here. And we're going to put a little bit of like red war paint underneath his eyes. So he's all like angry looking and stuff. This is a serious rabbit now. Nobody's going to mess with him. Now, why did I paint this? Well, I'll tell you why I painted this. I painted this because there are some of these 3D printers can actually paint colors onto the finalized object. So if you decide to go with one of these services, you could actually, with a pretty decent degree of competency and fidelity and things like that, paint a design onto your 3D model, and then either get it printed out at home or sent off to somebody to get it printed out with the colors on it and everything like that. So that is definitely possible. Let's give him some eyes. Doop. Yep, those are his eyes. Those are amazing looking eyes. Anyway, let's take a real quick look at edit, mirror. So under analysis, no, I'm blind. Okay, it's here in edit. We can create a pivot. And a pivot is exactly as it sounds. It is literally a point around which we can pivot the bear. So like, let's first midpoint along ray, and if we click and drop the pivot there, perfect. So click drop pivot and then done. So now we've got a pivot point over here. What did that do? Well, I'll tell you. So normally when we transform, we get this complex thing coming up. And we can move the bear around on all of the axes, excuse me. We move it around on all of the axes. By clicking one of these triangles, if we click one of the, arrows, if we click one of the triangles, we can strain it to a certain plane. So it cannot move along the X plane, it can only move along the Y and the Z plane right now. Likewise, it could only move along the X and the Z plane right now, and it cannot move along the Y plane. And then we can click these little things right here to rotate it, the little arcs. So I'll bring the bear back around. Let's just actually undo all of that stuff we just did. Okay. Yeah, back to transform. And then we can actually scale the bear as well, either uniformly or by specific dimensions. Make him squished bear. Totally flat. Heh. That's actually kind of adorable looking. Anyway, undo. Undo. Now, what good does this pivot point do? Well, you see if I click on the pivot point, I get another transform thing, right? Now, if I rotate it, this is not looking like super obvious, but I can rotate the bear around the pivot point now. The center point is the pivot point as opposed to the center point of the bear. We can also use that pivot point for mirroring, for aligning. We can use it for cutting. Duplicate is pretty self-explanatory. You can duplicate your 3D model. But what we're going to do is we're going to get it ready for printing. We're going to get it ready for prime time. So and it's going to spend some time thinking about it. And then of course we're going to get this thing over here. So now we've got make solid. We've got a few options. These are basically the fidelity of the render. So like how good you want it to look. Color transfer mode, vertex to vertex, and then we can increase the mesh density and increase the accuracy and hit update, and you'll notice once it's done, after a certain amount of time, boom, nothing's changed. Well, that was exciting. But that's kind of a lie, actually. Something has changed, and let me tell you. Accept. I'm going to click accept, because remember you have to click accept. Alright, well, it already opened the object browser for me, so the surprise is ruined. But if you go under view, there's view object browser. If it's already there, it'll say hide object browser. Or if it's not already there, it says hide object browser if it is already there. But you notice you got bunny R object, and this is our rabbit that we've had. And then we've got bunny.object, and then in parentheses it says solid. Solid is the one you're going to want to use for 3D printing. This other one is good for editing, but as soon as you're done with it, like as soon as you want to print it out, you need to make a solid version of it, and you do that with the make solid. That is how you do that. The rest of these, they as you get more, like if you get interested in this and you get more advanced with it, you can spend some time playing around with those. But for now, we're going to move on to analysis because it is 8:54. So first things first, you got a few things. You can use units/dimensions in order to change the dimensions of the bear, so you can see how big it is, and you can scale it down, and everything else will scale with it. I'm going to click out of that so it stays the same size. You can measure distances from certain points on the bear to other points, or the insides of it or anything like that, just to get an idea of how big it is. And I believe, yeah, it's in the way. And you've got the X, Y, and Z over here. Thickness is the thickness of the material, which can be important for 3D printers. Certain 3D printers require a certain thickness of material. So like it has to be, and when I say thickness, I mean if we go back to our model of the hollow and the solid cubes, in this case, if we look at the hollow cube, it would be the thickness of one of these walls. It would be the like how thick that part is right there. That is something that some 3D printers need to know and need to have a specific value in. So of course I clicked on it, and now it's going to spend forever computing it. Strength is sort of an idea of the tensile strength of it based on the material you're using, the thickness of it, and everything like that. There we go. These will tell you perhaps, yeah, various thinner points. But anyway, we're going to clear selection. Orientation, pretty self-explanatory. Stability, make sure that it can stand up on its own. It also allows you to move the model up and down, and you can see that if you do that, it changes subtly, but the base of the object does change. Layout and packing changes the orientation. We're actually going to click cancel there, and cancel here. Overhangs, make sure there's there isn't really anything like that's left hanging. So the overhangs here, what it'll do is it'll add supports. Oh, no, it won't. If we click generate support, it will. That's right. And then it'll create these weird looking supports here, like super weird looking. But these will be necessary as it's printing, because the plastic will be hot as it's coming out of the nozzle. We want to make sure that the first initial layers, like right down here, don't start to like droop and stuff. So that red stuff means that those will be like sort of warning zones, and that's why there are supports generated for those areas. Go back to analysis. Now the big thing that we're really interested in generally is the inspector. The inspector tells us where there are holes and where there might be too much material. Here it's saying that there's unnecessary supports, so we can click on those and it'll take those away. Although that's largely up to our discretion, so like we can probably get rid of that support over there, but whatever. We'll keep the support underneath the head. We'll keep these supports here, that kind of a thing. Now let's say there was a hole. So like let's go back to sculpt, and we will, oh, you know what? Actually, let's go back to select. Get this done as quickly as possible. We'll select this area right here, and then we will discard it. So now we got a hole there. Like we can look inside the bear. Hello! So if we go to Analysis and Inspector again, as you can see, it's turned blue to tell us there's a hole in here. So we click on that, and it'll try and autofill a hole. Right now it's using flat fill. If we undo that, and we go back into Inspector, and we use like smooth fill, and we click on it, then it will actually smooth fill the hole. It'll try and extrapolate the curvature of that area based on the area around it. Auto repair all will attempt to repair everything. We're going to keep from clicking that now because we've got all these which are saying that they're errors and these are supports, which is probably why you want to do the inspector first and then the support. And then finally export. Like I said, you can save it to your computer as an object file or as an STL file, and then use it in Fusion 360 or 123D Make. And then 3D prints. Almost done, you guys. No worries. Or sorry, rather, not no worries, but also no worries in case you were worried about getting out. If we go to prints, then we can see like the final setup before we send it off to the 3D printer. Now keep in mind, it's going to say, repair selected, add support, stuff like that. We need to put in this second one, the bunny.object solid, and it says model repaired, and there's a check mark, and it says valid supports, and there's a check mark. That means that this thing is ready to go. Once you've got those good to go, and it sits on the table, within the table, your model is ready to print. Now keep in mind that this is based on the MakerBot Replicator 2. If we go up here, we can click on this and see all of the different 3D printers that are in its database. So hopefully, if you have a 3D printer, your model appears here, so you can get the correct dimensions for the table. If you don't have a 3D printer and you have some money that you'd like to spend, you can go to one of these services up here. These top 4 are the 3D printer services. So we can go to iMaterialize, and it'll update the materials, and we will make sure you select your solid object again. And of course, okay, let's go to Sculptio so that we can see the materials that they have available. Because that's another thing too, you can select the materials that you're printing from. Alright, well, it's deciding to not respond. Anyway, you can select the materials, you can send it off to an organization, they'll print it out for you and mail it to you. Keep in mind, though, the cheapest print I've ever seen, it's been about $30. I'm sure, it's possible to bring the price down. I'm not going to say that that's as cheap as it'll ever go. It's just the cheapest I've ever seen it before. It's $30. I've seen it go up to $100. I'm sure it can get more expensive than that. So, don't use one of those printing services unless you have your parents' permission or you're willing to pay for it yourself. And just keep that in mind before you start going crazy with that kind of stuff. Anyway, this was meant to be just a pretty basic overview, so I'm going to go ahead and call it a lesson now. So I will throw out the poll questions. If you have any questions about the material we've gone over today, you're more than welcome to ask them after I'm done with the poll questions. If not, after the poll questions are done, you're more than welcome to head out. Have a wonderful couple of days.